Hi, everyone. My name is Jordan. This is Nestor and Ori. We're all from dOrg. We're here today to introduce a project that we worked on with the graph called the Graph Mutations. It's adding GraphQL mutation support to the graph subgraphs. And so a reason why this is super interesting is because it enables optimistic UI for Web3 applications that are reading from the blockchain, reading from graph nodes, and then also writing to the blockchain. And so you could imagine that, when you start up your application and you try to create something as a user, instead of being prompted immediately with a sign transaction prompt, you'll be prompted with the UI of what you're creating and then the sign transaction. And so funny that I bring up that example because I'm going to show you that right now. So let's go ahead and we'll switch to that. Here we have the app running in the foreground. Basically, this is an app that allows you to create these example avatars for yourself. And in the background, as you can see, the text logging, we have Ganache. There's also a subgraph running. And this app is connected to both of those. And so in order to demonstrate optimistic UI, I'll go ahead and I'll create a new avatar for my account. As soon as I click create, this is the part that's new, it's not currently present in most all Web3 applications, is this optimistic creation of what I am doing before the transaction is even signed. And so here we see my avatar. It's just like a randomly generated image and also a name. And it shows my address. And if I click reject, it'll actually roll back these changes. It says user denied transaction signature. I click OK, and it rolls back. Now let's go ahead and let's do it for real this time. Let's actually click accept on the transaction. And boom, we have finality. So this is now added to our app, and it's not going to go anywhere. And so next up, we'll show an example of being able to have progress updates. So with the mutation API that we had developed, we added the support to have kind of like an incremental feed of data coming back from this mutation that's executing in the background. So we say update name to let's say foo. We click on update, and it's going to basically give us a progress bar. And it's going to show us an incremental update of what's going on in the background. This is all just for testing. And so if we click confirm, that progress bar will hit 100%, and it'll set the name to foo. So that's cool and dandy. Let's also just show really quickly the rolling back feature of set this. We'll click update. If we reject that signature, or if a failure happens in the background, it will roll back those changes. And so see how it says state at foo. And so lastly, the same thing happens with removing that entity. So we remove it, and it is removed from our client's like local cache. But if we reject this, it's going to go ahead and do a refetch query, and it's going to go ahead and say that this is the actual current state. So yeah, optimistic UI and Web2 applications. It's pretty great. It kind of just, it helps with the instant feedback for users in your applications. And the other cool thing that I'd like to touch on really briefly here with this demo before we jump into talking about the code and how you can add this to your projects is the fact that the events that you are sending back, the state data of your mutation that's executing in the background, all of that can be customized. And so we'll show a quick example of that. If we open up the console, we go ahead and clear this. I had added just some example logging here to demonstrate this. We go ahead and we create this new avatar. And here we see some outputting. And so let's walk through what this is. And so I added 3 new events and 3 new state properties for those events to change. So in our state of our mutation that's currently updating, we have these 3 properties called current step, completed steps, and total steps. And the idea is to be able to feed back information to the user saying, this is what we're currently doing. We are uploading data to IPFS. We are signing something. We're validating some input information, et cetera, et cetera. So that way, as your user clicks on something that's doing things in the background, they can maybe have some intelligent UI letting them know what's actually happening. And so in order to change this state, we dispatch these events. So it's very similar to how, like it's the same exact model that Redux implements, if you're familiar with that. It's just a basic translation of events into a state. And so here we have the event total steps, and it says steps 3. And so this will set our total steps to 3 in our state. And so now our UI is actually being told of this new information. Next, we say set start step. We set it to 1 with like a little description saying connecting to protocol. Our current step is now 1, completed step 0, total steps 3. We say that we completed step 1, completed steps is 1, et cetera, et cetera. So now we have the next step starting, which is sending the transaction. So we've already connected the protocol. Let's send the transaction. And so we click confirm. And then once that finishes, it'll tell us we completed step 2 of sending the transaction, and it's going to do step number 3, which is fetching the gravatar from the subgraph. And so this is kind of an interesting case where the ID for the gravatar is actually generated inside of the contract. So we don't know about it until after that transaction has finished. And so in order to kind of like fetch and understand what your ID is, you could look at the events of the transaction receipt, or you could say, I'm going to use my subgraph data as the source of truth. I'm going to go ahead and fetch from the subgraph and get my new gravatar and display its new ID. Yeah, so that's events. Lots of cool things you can do with this. Yeah, so it's optimistic updates, incremental eventing, and state updates, and trying to just have more user-friendly UI with these long asynchronous actions. Cool. So let's go ahead and we'll jump into where we can actually look to figure out how to add this to our applications. So we created this repo in Graph Protocols GitHub organization called Mutations. What you can find here is the 2 different packages that are created to make this possible: Mutations and Mutations Apollo React. For if you're using Apollo and React, there's just some nice helpers here. In order to look at the documentation, there's a pull request currently open. Let's go ahead and we'll just change to that branch. There is a docs folder. And so in this docs folder, you can see the different user guides that we had created to let you know how to add this to your application. And so let's actually talk about that first from a dApp developer's perspective. What does this look like if my favorite protocol, let's say Compound, or some other Web3 protocol says that, hey, we now have a Graph Protocol Mutations package. How would I go about adding that to my application? So first and foremost is you have to instantiate the mutations. So here we get the example mutations. In the example I was just talking about, you could say that this is compound mutations. And so when we import their package, we also grab the create mutations function from the Graph Protocol Mutations package, and we call create mutations. In create mutations, we do a few things. We first off give it the mutations package. We tell it what the subgraph name and a connection to a node. And then we also configure it with different values that this package requires. So these are context-specific values. For instance, inside of a browser application, you may want to use the MetaMask, or you may want to use a direct connection to, let's say, a ledger. So the mutations isn't going to make that assumption for you. It's going to let the application configure the mutations on behalf of the user. So right here, what we're doing is we are grabbing MetaMask, and we're basically saying that the Ethereum configuration property is the MetaMask provider. And all of these are type safe. We certainly recommend using TypeScript, so that way, if you're returning something that's not compliant with the mutations package, you'll get a compile time error, or syntax highlighting will be able to help you out. And then lastly, we give it an IPFS node connection. So now that our mutations is instantiated, we'll just go ahead and try executing something. So we'll say mutations.execute, give it a query string, mutation example mutation with our variables. And this is kind of the functional way, or not necessarily the functional way, but the direct way to do this, not using, let's say, not using React helpers like with hooks or a DOM element with callbacks. So this is very much like, just a standard JavaScript API. You can use this in anything. And here we're executing our example mutation. And we need to provide two helpers for setting and getting the context. And then lastly, we get the return value, so data.example. We can get the state updates. And so when we call .execute, we can set the state subject. And so this subject will be basically updated every time the state is updated. So that's like if you want to receive state updates. And kind of like an easier example to look at is if we look at the Apollo React user guide. So here, the things that change is we create a mutation link. We add that to our Apollo client. And then now we're able to use mutation, just like we're familiar with saying use mutation, my mutation, here's my query string. And in the return values from use mutation, we actually get the state object. And so this will be filled with your custom state properties, like, for instance, progress or number of steps, current step, et cetera, et cetera. So here's use mutation again, and then there's also a mutation component. And so that is how to add it to your applications. And lastly, we'll touch on how to add this to your subgraph so that application developers can use it. So let's scroll down here to subgraph developer user guide. So first and foremost, we have to implement the mutation resolver package. And so there's a few things with this package. First off, we will define the resolvers. We'll say my resolvers look like this, mutation, example. These resolvers follow the same syntax as Apollo GraphQL client resolvers. And so this should be very familiar if you're already familiar with how to use Apollo GraphQL. And then, and actually, sorry, this format is actually, I believe that this is Apollo agnostic, but that's beside the point. And just a side note, like all of these packages are, well, the mutation package specifically is Apollo agnostic. And so if you'd like to use another favorite GraphQL provider, GraphQL client, you can feel free to do so. And then lastly, we will add the configuration, which tells us that we need an Ethereum and an IPFS provider. These types that you define map to the types that the app is returning. So this is a nice way to be able to say the app needs to give me an async sendable interface for ethers, for example. And we have the mutation state. And so this is where we can define our custom state properties, custom events. This maps an event name to an event type. And then we have our reducers that handle these events. And altogether, this is what this looks like. So these docs don't kind of put this, they don't put this in the context of a full application because your mutations is only one part of your full application setup. You would also have your subgraph with its mappings and its manifest. You would have your DApp with its UI. And so there is a project called Registry Starter that I'd recommend going to look at to see how we have this set up. We have a contracts folder here, a subgraph folder, and inside of this we have our mutations project. So here's the mutations project. And then if we go back to the root directory, we have our UI as well. And there's just simple scripts. Just go ahead and follow the setup instructions. You just go ahead and install all of your dependencies with yarn, run yarn build and yarn start, and that will set up the whole environment for you with the subgraph, ganache, deploy the contracts, deploy the subgraph, and start up the app. An important thing to note here is that the mutations are running inside of your application. So these are locally resolved mutations. If you're familiar with like remote resolution or local resolution with GraphQL queries. And then we also developed a specification for this whole thing. So if any part of this is funny to you or it doesn't quite make sense, the specification might be a great place to start. You can go ahead and scroll through here and look through kind of like the main goals we're trying to solve, the terminology that's at play, and then what the implementation details look like. And you can fork this, make edits, propose edits. It's an open specification. And I think that pretty much does it. We also have some other documentation on the Graph's docs website that isn't merged yet, but when that's live, you'll be able to read through that. It's a bit more in detail than the repository docs, which are pretty bare bones. And I think that does it. And of course, feel free to reach out to any of us at dOrg about this project. Feel free to go to our website, dOrg.tech. Find us on Twitter or send an email to contact@dOrg.tech. Yeah, so that is my spiel. Ori and Nestor, do you guys have any questions and anything to add, or yeah?
Yeah, could you explain a little bit more about the resolution of the mutations? Is there added trust assumptions or a threat model that anyone should be worried about?
Yeah, absolutely. So yeah, so like I was saying, the mutations are run inside of your browser just like any other like node package, let's say, that you add to your browser application. And so it basically has the same like threat model as, let's say, like another node package that you would grab for some other protocol. For instance, like Maker.js. You know, like in order to know that that package is doing the proper thing, you would have to look through it and see what transactions it's forming on behalf of your user. Yeah, so you know, yeah, it's just like any other node package. It's bundled into your application. And these are not remotely executed on some server that could choose to change, you know, a parameter in your, for instance, like in a granting permissions to a contract to spend on your behalf. You could you can nefariously set like the spender address to some other address and then drain someone's funds. So yeah, there is no server that can change kind of out from under you.
Are there plans to ever have this executing like on a server to make it gasless for an end user?
Totally. Yeah. So in order to make a gas list, like you could just do kind of like gas station network things where you can have a relay or pay for your users, aka like you pay for your users as the dApp developer. Looking towards the future, yes. Like we've talked to the Graph about potentially a spec for running this on a Graph node. And that there's nothing concrete set out, but it is potentially possible to try and make that trustless the same way that the Graph protocol is making this network of Graph nodes that are making querying trustless to basically validate the responses that these nodes are giving to users of the current state of the blockchain. You could do something similar where every time a signature is requested from a node, you could check amongst all of the other nodes to see if they both have that same signature that they would have requested to the user. So that way a single node couldn't change some properties on this message you're signing to do nefarious things. So that is definitely possible, and but yeah, it requires, you know, lots more building. And another great advantage of doing it server side is that now um, your interaction with a protocol, reading and writing, is completely done through GraphQL query strings. And so you can very much like execute this over any like HTTP connection, and there's nothing language specific about this. So it kind of allows any Web3 protocol to be able to be used in any application, not just browser applications. And this isn't currently the case today because a lot of projects develop a JavaScript wrapper for their protocols, which does a lot of heavy lifting for the app developer. So this would allow easy integration of any Web3 protocol into any type of an application, not just a browser application.
Awesome.
Yeah, and another thing I wanted to highlight about this is because it is something that came up asked questions many times while we were developing this, is that GraphQL specification allows for multiple mutations inside the same mutation query. And the way we approach this is actually in a way that makes our packages or mutations packages support these multi-mutation queries. And the way our state dispatcher dispatches these kinds of events is separate. So if, for instance, you call mutation A, B, and C inside the same mutation query, you'll get a state object which has mutation A, mutation B, and mutation C as separate state keys. So you can actually separate state dispatching even if the multiple mutations are in the same query, which I think it's a big advantage and makes our packages support edge cases of the GraphQL specification. And it's something that I think it's a pro.
Yeah, I definitely agree with you, and I'm just trying to find really briefly the documentation for talking about that, because I think that we removed that from the RFC, but yeah, I just got the document right here, so I'll pull up kind of exactly what you were talking about. Yep, so here, as you can see, we have a mutation with 2 instances of my mutation being executed, so a single query document with like 2 different resolvers being requested. And as Nestor was saying, the state object, you can reference your values by saying my mutation dot my value, my mutation underscore 1 dot my value. And so this is the second one. Yeah, so being able to support multiple mutations.
Yeah, and also even if Apollo is not necessary to use your packages, the Apollo React mutations library that we built on top of Apollo for React is actually very easy to do because the wrappers we implemented around the mutation hook and the mutation component share the same interface as the native Apollo mutation and hook. So there's actually no need to explain how to use those because they are used the same way as the Apollo ones are used. It's just that they return an additional state object, which is something that we added. But aside from that, that's pretty much it. So they're very seamless and easy to use.
Definitely. Yep. Yeah, and just showing an example of that, like here we're importing use mutation and the mutation component from the package mutations Apollo React, and then yeah, just like Nestor was saying, it's just like using it normally from Apollo, and you know you can get all the typical values you would expect with the addition of this state value that gets returned here. So the same exact interface.
And that way we can leverage the way that Apollo handles optimistic updating without needing any additional configuration or implementation of our own, because the way we designed this it was in a way that we could configure optimistic updating in the same way that Apollo does, like if we were in a Web2 application, and it would work like pretty much the same way. So we're achieving optimistic updating without any need for additional configuration. It's, yeah.
Totally. Yep, standing on the shoulders of Apollo the giant. Awesome. Cool. So if there's nothing else to add, I think that we'll conclude it there. Thank you if you made it this far, to whoever is listening to this. Yeah, and also thank you to the Graph for the opportunity to work on this project. It was a pleasure and a blast, and really excited to see where it goes into the future and kind of the improvements to Web3 UX that come of this. All right, take care, everybody. Bye.